So in Part E, we are given a linear program in 2 variables and with 5 constraints counting the non-negativity constraints. Just like every other problem of this type, our first step is to sketch the feasible region. So remember that the feasible region is determined by our 5 constraints. Now to save time, I've actually sketched out the feasible region already to the right. The basic idea is this line here will come from our first constraint. This line comes from the second constraint. This line comes from the third constraint. And then the non-negativity constraints tell me that the entire region is in the first quadrant. Now there's a little bit more to it than that in terms of sketching out the feasible region, but if you're unclear or can't remember how to do that, then jump back to section 5.2 and you can review the concept there. But at any rate, once we have this feasible region sketched, our next step is to find the vertices, to find where the lines or the edges of my feasible region intersect. So I have 5 vertices in this problem, for this feasible region. One of them is 0, 0, the origin. Another is 3, 0, 0, 3, or in other words, y equals 3. I also have x equals 3. And then I have these other 2 points further out. Now for those, I'm going to use 1.e-f to find these vertices. This one at the top here is at the intersection of lines 1 and 3. So if I find their intersection, I get the point 2.4, comma 4.6. And this other vertex falls on the intersection of lines, I believe that's 2 and 3. And so using the 1.e-f function in the calculator, I get that this vertex is 4.8, 2.2. So now that I have all 5 vertices, the next step is to plug each vertex in to the objective function. So I want to plug it into this function, which we haven't used so far. So I'm going to calculate each of these, and then I'm just going to write the numbers next to the feasible region. If I plug the origin 0, 0 in to this function, I'm going to get 0 plus 0 plus 7, so that gives me 7. Plugging in the origin gives me 7 back out. Now if I plug in y equals 3 and x equals 0, then I'm going to get 31. I'm going to get 0 plus 24 plus 7, which is going to give me 31. Plugging in x equals 3 and y equals 0 gives me minus 2. And then plugging in these other 2 points, I'm going to get, let's see, this one's going to give me 36.6. Of course, I would use a calculator to calculate these. And plugging this one in, plugging in x equals 4.8, y equals 2.2, is going to give me 10.2. So now I just need to compare the values at the vertices to see which one gives me the largest and which one gives me the smallest value for the objective function. And those are going to be my min and my max. So the largest number here looks like it's 36.6, and the smallest number is this minus 2. So I will summarize my answer as follows. I have a maximum of 36.6 at the point 2.4, 4.6. And then I have a minimum, or if you want to just abbreviate that as min, M-I-N, of minus 2, which occurs at the point 3, 0. Okay, so remember the process here. Step 1, sketch your feasible region. Step 2, find the coordinates for the vertices. Step 3, plug all of those vertices into your objective function. Step 4, identify your minimum and your maximum. Okay, let's do one more problem of this type. This is similar in that it's another linear program with 5 constraints, counting the non-negativity constraints. So these are the 5 constraints that are going to determine the feasible region, which I already have sketched out here. Let's see, just again, I'll let you review the process of how to actually sketch this out, but to help you understand what the picture looks like, I believe, let's see, this is the first constraint. This should be the line resulting from the second constraint, and this is the line resulting from the third constraint. Okay, so once I have all of the lines drawn and I've determined which side of the lines that I want, I can then sketch the feasible region, and now it's time to find the coordinates for my vertices. Just like before, I'm including the origin 0, 0. I also have this point 0, 4. This point 6, 0, or just x equals 6. And then I have these 2 points further out. Let's see, this one is at the intersection of line 1 and 3. And using the 1.e-f function in the calculator gives me 2.85, 2.96. And down here I get 5.09, 1.36. Now I plug each one of those values into my objective function, each one of those points into my objective function. Plugging in x equals 0, y equals 0, I get 3. If I plug in x equals 0, y equals 4, I get 0 plus 20 plus 3. That's 23. And now I'm going to plug in x equals 6, y equals 0, so that gives me 36 plus 0 plus 3, which is 39. And for these last 2 points, I'm going to use a calculator. So if I plug in x equals 2.85, y equals 2.96, I'm going to get 34.9. And then plugging in this last point, x equals 5.09, y equals 1.36, I get 40.34, which I believe is my maximum. And my minimum in this case occurs at the origin, and that's 0. So I need to summarize my answer. I get a maximum of 40.34, but I also need to state where it occurs at. And the max occurs at 5.09, 1.36. And then my minimum is 3, and it occurs at the point 0, 0.